Oh, hey there, this is Jake, and welcome to the fourth of our series of short tutorials to try to get you guys into the mood for using Matlab and some of the nuances and useful features that we like to take advantage of in 3E04. So today we're going to do something a little different than what we've been doing recently, and you'll see that I've started a new file. I've called it T4main. It's over here, and it's also in my working directory right there. And now the reason I called it T4main instead of T4 as opposed to T3 and T2 like I had before is because today we're going to learn about implementing functions. So there are a lot of functions in Matlab. For example, in the last few episodes we've had the plot and zeros and rand and all these different functions that are already built into Matlab. But what we're going to do today is make some of our own. So I'm going to have some different file names all in the same directory. What we're going to do is make one not exactly long, but like one code that's going to calculate some sine and cos functions and then plot the results on a nice pretty graph. And then what we're going to do is we're going to take all of the jargon and junk lines out of our main code and put them into some nice simple functions, and our main code will look nice and compressed and easy to read from that point on. So without further ado, let's get going. You guys will see how things work as we proceed. Mainly we want to take a look at the syntax for functions and that sort of thing. But before we get started, we are going to have to start with our critical 3 lines for our code, which are what? Close all, clear variables, and CLC. So let's get those in there right away because we don't want to forget. I can't stress enough the importance of this kind of just kind of structure, or just just maintain some sort of routine, I guess, when you're making your code. Try to get those guys in there because it always gets so annoying. The last thing you want to do is overwrite your own variables, so the second time you try to run your code it doesn't work. It's just not good for anybody, especially your TAs. So we're going to calculate some random sine and cos functions here. I'll just make them up as we go, and what we're going to need for this is an x range. So let's plot. This is going to be between I don't know, let's say -5 in steps of 0.1 and 5, kind of like this. So that's going to be minus pi and a half, 0.1s up to like pi and a half, that sort of range. We'll see what ends up happening there. And now I'm going to get yelled at by Matlab for having these brackets because I like to put the brackets around my vectors, but I guess we just want to make sure that we don't have anything and we have that green square up there. So if I run that and I call up x prime, so it's easy to look at, you can see that I go from -5 to 5, so that's perfect. That's exactly what we need. Everything is working correctly. So now let's make a calculation section here. So I'm going to make these two little areas. So let's calculate two different functions, one a sine function, one a cos function rather. So let's call the sine one y. So we're going to do y equals, I don't know, 2 times sine of x minus 1. I'll just shift it a little bit there. Now bear in mind that I don't need the dot multiplier here, even though x is a vector and sine of x is going to create a vector as well. And that's because, remember, this is just scalar multiplication. There's nothing to stop me from putting the dot there. It's just not going to actually do anything right now. So I'm just going to go ahead and keep it away. So there we got the y. And then let's do z. And we'll call z 1.5 times cos of x. And let's shift that up by a factor of 2. Why not? So there we go. We got our two functions there. Let's run that, make sure we don't have any issues. Call up y prime just as an example. There you go. We got our information there. We've got some minuses and pluses, which is good because it is a sine function after all. And now what if I were to see what it looks like? Well, one really cool thing that you can do, well, it's not really cool, it's kind of basic really, but if you just want to see what the shape of what you're looking at is, just doing a basic plot in your command window over here and throwing in this case, y. Don't even need to give it any x data. It'll just enumerate all the entries in y from 1 to 101 in this case. And what will happen is you'll just get this nice basic, kind of ugly looking plot, but you can just kind of see what the shape of this thing is going to be. And I said that there's 101 entries because over here, if we were to do the length of y, for example, we should find that we have 101 entries because that is, after all, the length of x, as you can see right there. So let's get rid of that. Now, what we want to do next, so this is going to end up being one of our functions. I'll just drop that right now. But what we're going to end up doing first is let's plot that information so that we can make a nice looking plot, and then we'll put this into a function and then all the plotting stuff into a function. So our main file is literally going to be 3 lines. It's going to be, not including these, it's going to be this guy and then a thing that calls our function and then a thing that calls our other function. It's just going to be nice and short and sweet. It's going to look pretty sweet. So the first line that I'm going to call up here is figure. Now this is optional. What happens if I run this with just figure? I'm going to get a box that comes up. It's called figure1, and it doesn't really do much except for just make a new window. So it ensures that you got a new window. I like to throw it in there every once in a while just to ensure when I'm running through my own code, I notice, okay, I'm making a new graph right here. That's what that's going to be. So let's throw in a comment, new graph, exclamation mark, 1, 1, 1, exclamation mark, 1, exclamation mark. There you go, perfect. Beautiful. So then also let's do the hold on command, because we know that we're going to have to plot y and z, or at least I would like to plot y and z on the same set of axes. So I'm going to want to do that. And then we'll go ahead and do the hold off command down here too, because I don't want to forget to turn that off, lest we end up plotting something else on the same axes, which will, potentially end up looking like garbage. And then let's go ahead and plot it. So, we'll throw in our x data and our y data. For this, we're just doing the sign command right now. And in single quotes, I can choose what color of line I want. The default is blue, by the way, as you noticed on our original just plot basic command that we did. But I'm going to add in a couple of options. Instead of just R for red, I'm going to say R line and O. So the O means circle markers, and the dash means I want to have a line in between them all. And then let's do one more option, line width, as we did with the last time, because I find the default line width to be very thin and gross, and we'll make it a 2 instead of a 1. So a couple of things I want to point out. I thoroughly encourage you guys to check out the doc plot command, or of course doc anything command, to check out all the different types of options that you can do when you're making graphs, because there are tons of different options. And like I mentioned, I think in the second or third tutorial, going through that document and just taking a look at the examples and showing or taking a look at their example lines of code that they typed in, and then actually seeing what the result of that is, kind of really gives you a feel for what you can do to make your graphs look better. So like you can do things like change the marker face color, make it there or not, the marker edge color, all the basic things that you can do basically in Microsoft Excel when messing around with your plots there, you can do in Matlab as well, and it's a lot less time consuming than you might imagine. You might say, well, I don't want to plot all or like type all this stuff in. But by the end of the day, once you get used to it and you can start to copy and paste your templates or use functions for your templates in Matlab, it gets right down to the same amount of time that it takes to click around Microsoft Excel to try to get that stuff. And I'm a huge fan of Microsoft Excel, so I have no bias toward Matlab in that regard at all, but you just need to kind of open your mind to the different options. So anyway, just a little brainwashing activity there. I'm going to copy that line down. I'm going to go with the Z data now, which is our cosine. And I'll make these ones black, so that's K for black, and then I'm going to also have a line with circle markers, and then I'm going to have that line width is 2. And then let's put in our axes titles, so let's call the x-axis X, and the y-axis we'll call Y and Z, just like that. And then let's put in a title. The title can be plot of sine and cosine functions. And then we'll throw in, why not, a legend. So if you remember from last time, the legend, you put in single quotes the name of whatever line in the order that they were plotted. So in this case, the first one is the sine function, so why don't I just go ahead and put in 2 sine of x minus 1, because it's just going to be a string, and that's just going to be a nice little equation up there. And then this one I can have like 1.5 cos x plus 2, because that's what we had. And then let's throw in some, I'm forgetting my semicolons here. With plotting commands, semicolons usually aren't critical, but it's just good practice, it never hurts. Let's make sure that the box is on the plot, because I like that. And let's do legend Let's do box off, because I don't like the box on the legend. Personal stuff. And then we'll delete some extra lines here. And that should be it. So let's see what happens when we run this. Hopefully we get no mistakes. No, we got no mistakes. If I bring in our plot over here, you can see that we've got 1.5 cos x plus 2 and 2 sine x minus 1. So there you go. I can go ahead and maximize that and take a look at that sort of thing. And then, you know, the way that we've written this function, or not function, sorry, code, like if I wanted to change this to be 0.01 instead of 0.1 and get a whole bunch more points, it's as easy as just changing that and then clicking run. You can see that we've got a ton more points in there. They are so close together that you can almost not even tell. So there you go, those are the points, much closer together. So there you are. And you can change the font size of all this stuff as well as you're going along. I'll let you guys take a look at that in your own time because it's not entirely important for this. So that's our finished code, and you know, it's only like, say, 29 lines, including a few comments here and there, so that's not that bad. Pretty basic, but let's try to make it a little bit shorter. So what I'm going to do is I'm going to collapse this guy into a function. So functions in Matlab are they're not terribly difficult as long as you just get used to how they're called. So there's usually two ends of it. The first end is the actual function that you write, and the second end of it is the where you call the function. So here we go. I'm going to make a new function, a new script up here. So new. It's called Untitled 2. So here's the first line that you always put into a function. So you can put some comments, and then I could say, like, you know, function that calculates x, or sorry, not x, y and z, because those don't count. But the first line of the code has to be the word function. And as soon as you do that, when you save this, it's not going to save it as an M file. It's going to save it, it's going to have a little f at x over here in your work folder, which means that it recognizes this as a function. So here's the syntax. It's always function, and then variables it's going to calculate, and then equals, and then the name of the function. So I'm going to call this T4, you know, sine cos. You get to make this up, right? And then whatever the function is going to be given in order to do its calculation. So in this case, I'm going to be given x. So out here, you see that I'm passing in x, so I'm going to call it x up here. Now, one thing about functions that you could, you know, might want to know is that inside a function, unless you're dealing with global variables, which you should almost never do, what will end up happening is that the variables in this function have their own name and they don't care about the rest of them. So I could call this x and I could pass in x. Pass in means like put it in the square or the curly brackets there. But in here, you know, I may as well call it bananas or something like that because it doesn't really matter. So I'll just show you what I mean. So, and then to end a function, you just want to put end. So now here's the thing. You should never run a function. If I try to run this, I'm going to get a bunch of errors because you should never run a function from this command window. What you can only do is call a function either in your command line or in a main file. That's why I call this one the main. This is the one where I'm going to press the play button. In functions, you can't really press the play button. So what I'm going to do is I'm going to save this, and now it's going to open up. Now here's something very critical. What you have to always do is save the function in the same directory as your main file. So there's T4 main right there. And then also you have to save it exactly as you wrote the name right here. So I called it T4 sine cos, so it's going to give me the default T4 sine cos. So I'm going to save it just like that. And now if you ever save it as something different, you're going to get a warning here that it doesn't recognize this function. And sometimes that happens, like say you're going through and you change it to be T4 sine cos 2, and then you resave it, but then it's saved as T4 sine cos, so you're going to have to save as and fix that up. And it's going to give you this warning. It's not known to, there you go, see, it's not known to Matlab by that name. So I'm going to have to get rid of that. So now in where these export variables are, I'm really just going to export y and z. So in square brackets, you put in what you're going to export. If you leave the square brackets empty, it doesn't export anything, which is like possible a lot of the time, and which will end up happening with our plot code actually. But if you are going to export variables, then you have to type them in with a comma in between them in here. And it's going to say that we're not setting these values, but as we type the equations in, it's going to go ahead and it's going to recognize what we're doing. So now what we can pretty much do is take these two equations right here, because y and z are going to be calculated, we're going to copy them and put them right in here. And now the only thing we need to do now is that this isn't a function of x, it's a function of bananas. So we may as well put bananas in here. Well, not may as well. We have to put bananas in there. If we put in x, it's going to come back and say, I don't know what x is. So here's an example. If I press the run button, it's not going to work. It's going to say, not enough input arguments because I need to put in bananas into this function, and if I just run it, it doesn't know what that is. So what I'm going to have to do is pass that value in somewhere else. So what I'm going to do is pass it in right here. So that's the defining the function, and now calling the function. It's going to export these two variables, y and z. Now I don't have to call them y and z out here, but I'm going to. So y and z. And I'm going to say equals, and then I'm going to call my function. Just like I called, say, the zeros function, I'm going to call mine. So I'm going to call t4 sine cos. And then I have to pass in a value. So this thing considers it to be called bananas, but in this thing, I'm going to pass in x, because x is what I've got right here. And as soon as x goes into this thing, the function reads it in as being that bananas function. I really don't know why I use bananas, by the way. Or not function, rather, but variable. It's going to just say, oh, that's what bananas is, and then it's going to pass that value in there. So I may as well just have x's here, here, and here. But the point of having this other word in here is that it just doesn't matter what you do. So I'm going to go ahead and do that. So there you go. And now what we've done is we've taken those two lines, we've collapsed them into one line. If I run this, what will end up happening is we get the exact same result as we had before. So what we end up doing is getting y and z just like we calculated them individually, but we calculated them in our main file in one line, and in our one line it went in here, it said here's x, it came into this thing, it said there's x, so calculate y, calculate x, now, or z rather, give y and z back, and then it gave y and z back right there, and then it continued on. So there you go, we used a function, and it wasn't so bad. So the last thing that we're going to do is say make a plotting command. So let's get rid of this whole thing right here. So new, and then we're going to call this function, and then I'm going to call it, it's got no outputs, and we're going to say those no outputs are equal to t4 plot, and then end. So now I'm going to save this. It's going to come up as t4 plot. That's fine. Let's do that. And t4 plot is actually a function of, I forgot the inputs, but we're going to need x, y, and z, basically, because all of this stuff is going to require x, y, and z. Everything else we kind of just have typed in there. So it's going to require x and y and z in that order. So the order that you write them here is the order that they're going to be used in there. And so the order that you pass them into a function, just like with this x, if it had more than one input argument, say x and y, I got to pass them in the correct order. So there you go. That's going to happen. It's going to warn me that I don't use any of those, but we're going to fix that very soon. So now what I can do is just copy this guy right out, copy it, throw it right in there, that whole thing, get rid of some extra lines. I'm going to save that. It's going to recognize that we got x, y, and z in here now, because here they are. See, you can see them all floating around like that. And then I'm going to comment this whole thing out, because I don't want it to do anything anymore. And then I'm just going to call my plot function. So since there's no outputs, I don't have to have anything equal to it. So I'm just going to have t4 equals, or sorry, t4 underscore plot. And I'm going to pass in x and y and z. Semicolon. And that is basically it. So I'm even going to throw in a line down here. I'm going to make it print out ran the plotting function, so we know that it's going to print this out if it gets into this plotting function properly. So I'm going to go back here to my main file, close that guy off, and now if I run this, what is going to happen? We ran the plotting function, and we have the exact same graph that we had before. So at the end of the day, if I wanted to, I could just delete all these comments that I don't need, and what you end up having here is a main code of 1, 2, 3 lines. And all the nonsense that you don't want to have to look at, like all this purple text in here that nobody likes. Let's throw in a new line after that. I just realized that we need a new line there. See? But anyway, I'll save that up. That will work, and we are in good shape. There we go. And we have made 2 functions. We've condensed our main code. It was very successful. One thing that I want to mention is every time you change a function, so let's say I also want to print off yay, because I'm a little excited that I've been doing this cool stuff. Now, if I run this, it's not going to print that out. Now why? You see the little star up here. What Matlab does in the main file, when you press run, it'll automatically save your file and run it. But if you have a function and you have not saved that function since you've last changed it, which is what that little star means, which I didn't do there, then the function as it's called in the main file doesn't get automatically saved, and you're going to not have that work. So sometimes if you adjust a function and it's not doing what you think, maybe one of the troubleshooting causes, you can go back and make sure that you've saved it. So now that I've saved it, I press run, and now I get an error. My first error of all these tutorials, and that's just because I mistyped fprintf. I missed the F on the end there. So now if I save that and I run this, I'm going to get yay, and then over here I've got my graph as it popped up, and we're in good shape. Anyway, so I hope that you learned a little something about making functions there, and that was useful to you. If it wasn't useful to you, I'm really sorry that I just consumed the last 22 or so minutes of your life. But anyway, I think we're going to do one more tutorial. Well, it'll be number 5, I guess. And what I'm going to take a look at is like troubleshooting, inserting breakpoints. That's what those nice little red circles there are. We're going to talk about putting in breakpoints and trying to troubleshoot problems in your code, and then some, common mistakes that I hate. But on top of that, they're inevitable, and hopefully maybe you guys will get some troubleshooting expertise so that you're able to go ahead and find those mistakes without banging your head against the wall. So, as usual, thanks for watching, and I hope this was helpful. Again, any feedback, just go ahead and send me an email or talk to me in a tutorial or something like that, and I'll see you next time. Alright, have a good one.